up, athletes? Whoop, whoop. All right, let's get to this. This is 1.2 algebraic expressions. And our learning target today is I will write and evaluate algebraic expressions. Go ahead and take a minute, pause this video, and fill out this warm-up. See how you can do on that. All right, I'm assuming you crushed it. So let's just do it. -5 minus 6, really didn't need those parentheses, right? This simply is just, -5 times -6, not -5 minus 6, duh. -5 times -6. Negative times a negative is a positive, 5 times 6 is 30. What was I thinking? I need to drink more of that coffee, you know what I'm saying? All right, negative divided by a negative here is a positive. 81 divided by 9 equals 9. Boom. Right here, now we just have a multiplication sign there. Again, negative times a negative is a positive. 5 times 2 is 10, so I'm left with 10 times 3, which equals 30. Okay? And the last one here, I have a positive divided by a negative. Well, that's going to equal a negative. Okay? What's 54 divided by 6? That's -9. Boom. There's your warm-up. Awesome. Let's get to that vocab. Before we get to that vocab, though, just some interesting facts here. So concert ticket sales in 2014, an average concert was $82. Whoa. It's a lot more now. I think it was like 150 last I checked. 2014 concert ticket sales revenues in North America amounted to $6.2 billion. That's how much they made. Thinking about that, I bet that's up closer to, well, I don't know. It kind of went down due to the COVID, but now we're back, getting back up there. So be curious to find out what 2022 looks like. About 20% of Americans attended a concert in a given year in 2014. Check this out. The largest audience for a concert was about 4.2 million people at Copacabana Beach in Rio de Janeiro, Brazil. Think about that. That was in 1994. Consider 4.2 million people at one place. That's crazy. How about this? The longest concert was 372 hours and 10 minutes. Let's see. That is 372 divided by 24. That is almost 16 days long. Dang! From October 1st to October 17th. Look at that. Crazy. That's no surprise. 91% of people listen to music, okay? Average time an American spends listening, 24 hours per week. A day of your week is spent listening to music on average. Some of you much more than that. I would argue much more now. I bet it's around to 2 days. Live music is about half money spent. Interesting facts here. So anyway, just thought I'd share that with you, but we got to get on to the vocab at hand. Just going to open these up, and I'm going to tell you, I'm not going to sit here and wait very long. We got variable, which is a letter used to represent an unspecified number or value. Anytime you see a letter in math, it just means some number. Algebraic expressions are expressions like our numerical expressions, but they have to have at least one variable. A term is a number, a variable, or a product or quotient of numbers and variables. To define a variable is to choose a variable to represent an unknown value. All right, pause this, but we are moving right along. Okay. So I'm going to go right here. I want to look at this expression, 0.5x plus 2. And let's label this, what in the world? I'm away. Let's label these different parts right here. So in here, the variable is x. The algebraic expression, right, is the whole expression, 0.5x plus 2. Now, a term doesn't have to have a variable in it. A term is just a standalone or a number times a variable, right? So we're going to have one of the terms is 0.5x. This is a term, and comma, and this is our second term, 2. Now, what is the variable term? That has to have a variable in it, either through multiplication or division, and in this case, it is just the 0.5x. The constant term has to have no variables in it, and in this case, that's 2. Now, not every expression has a variable term, not every expression has a constant term. Keep that in mind. So let's write down. This is similar to last week where I said how many different ways can you write down 2 times 3. You should look at your old notes to cheat on this because it's going to be the same. Simply just x times y with the parentheses, x times y with one parenthesis, and x times y with another one parenthesis. What about writing 3 minus x? Believe it or not, we can write that in different ways. Can't I write that as 3 plus negative x? Because what does a plus minus make? Oh, wow. Come on, don't run out of ink on me now. Plus minus makes a negative, right? I could also write this as 3 minus x. I could also write this as 3 minus x. Lots of different ways we can do this, so just keep that in mind, guys. All right. Let's talk about operations and verbal phrases. So just looking right here, we're going to... And here we go. We'll see addition can be written as more than, sum of, plus, or sum, plus, increased by, or added to. Subtraction is less than, subtracted from, difference, decreased by, or minus. These are all the different ways you can use words to write. Subtraction, all the different ways you can write multiplication, product of, multiplied by, times, division. That weird word quotient. Quotient of means divided by, same thing. And there's some other ways, but these are kind of the general. Take a minute, write these down in those provided boxes, and we're going to go back. Pause this because we're heading back. Ready, set, go. All right. So you'll notice we have ours written down right here, and we're going to use this to help us write a verbal expression right here. So what do I have? Well, let's just talk it out. This says 5 times x cubed plus 2. How about we just write out what we said? What did we say? 5 times x cubed, I'm going to say, I could say x to the 3rd power, plus 2. You know, I could say this in a different way as well. I could say the product of 5 and x cubed increased by 2. Now, I'm not going to do that very often. I prefer to go the easier route, but I want to make sure you see this because you will see this type of writing. You need to know what it means. Okay, let's look at the next one. What am I going to write for the next one? Well, it's 1/3 m to the 5th power plus 12. Seems easy enough to me. So 1/3 times m to the 5th power I'm going to say increased by, just to be fancy. Increased by 12. Might as well. Take a minute, see if you can write this down. Ready, set, go. This is an interesting one. We didn't talk about this really. Okay. Hopefully you paused it, had a chance. So I'm just going to again say a to the 4th power plus, and here's where I'm going to say it a little differently. You could say 6 times b divided by 7. I'm going to say plus the product of 6 and b divided by 7. This last one's interesting There's probably a word we should add to our notes, which is quantity. And over here I'm going to write parentheses. And then over here I want to write quantity. Or sum of product of. We already talked about this really. Quotient of. In this case, when I see 5 and I see a parentheses there, I'm going to say 5. What did I just write? 5 times the quantity when I say times the quantity, I mean whatever's next is going to be put in parentheses. I could have also said the product or the sum of, 5 times the sum of, would have done the same thing. 5 times the quantity, z squared, or z to the second power, however you want to say it, z squared plus 16. Boom. Again, take a minute, pause this if I went a little fast. Let's keep rolling.